Java class loaders support a delegation model when it comes to loading classes. Typically in an application, there are more than one class loader. For example, there's the class loader that needs to load the extension classes and the class loader that needs to load the base classes. And these class loaders typically exist as a hierarchy. And each of these class loaders has a parent apart from the base class loader. That's the top of this hierarchy. And a class loader may delegate to its parent. Now, we say may, typically this is the behavior. And if you use the built-in class loaders, and if you derive from the built-in class loaders, this is the behavior you will get. However, there's nothing to say that when you write your own class loader that you have to delegate. You can do anything you want to in your own class loader. When a class loader delegates to its parent, then that parent may load the class. And again, the parent does not have to load the class. There are some rules, however. If a class loader loads a particular class once, it must load it in the future. And typically, class loaders load a class once. So once the class has been loaded, it's cached, and the same instance of that class is returned when it has to be loaded a second time. And again, if you use the built-in class loaders, this is the behavior you'll get. So, for example, if you load a very basic Java console application, you'll end up with 3 class loaders. You'll end up with the application class loader, whose job it is to load your classes and any classes loaded from the local class path, say. You'll end up with the extension class loader, that we've seen already loads from the extension directory, and you'll end up with something called the bootstrap class loader. Now, the bootstrap class loader in the Oracle Java VM is written in C, so it's not actually written in Java. The other class loaders, the extension class loader and the application class loader, however, are written in Java. And typically what happens is this. The virtual machine asks the application class loader to load a class. And the application class loader will delegate. And they will delegate to the extension class loader, which will delegate to the bootstrap class loader. At this point, the bootstrap class loader may load the class. So if it's java.lang.string, the class loader will find the string class, load it, and return that data back down the delegation. However, it may not be able to find the class, in which case that load will fail and come back to the extension class loader. And the extension class loader will now try and load the class itself. So it will look in its set of jar files and its set of directories to find the class. And again, if it finds the class, it will load it. If not, it will fail, and that gets passed back to the application class loader. And the application class loader at this point, again, has the same option. It will try and load the class from its set of directories, its set of jar files, and if it succeeds, loads the class, or it can fail. We'll get our famous no class def found error. Each time one of these class loaders is asked to load a class, it will first of all check to see if it has previously loaded that class, and if it has, just return the same class from the cache. So in this case, when we load the class up, we only ever get one instance of the class in memory. So the class type for the class is essentially a singleton, or at least you can think of it that way. And we can write code to see this delegation, and we'll do that now. So printing the delegation is actually quite straightforward. The first thing we'll do is grab a reference to the system class loader. This is the class loader that's been loaded to load the current set of classes on the class path. The method is defined to return something of type class loader. It actually returns something of type URL class loader, so we can safely cast it here to be a URL class loader. Once we have that, we can then add a loop. And the loop simply says print out the class loader and then call this class loader's getParent method. And while that doesn't return null, go back around the loop and then print out the class loader again. If getParent does return null, we're at the top of the hierarchy, and that means we've now reached the bootstrap class loader. So we simply print out the fact that we have that loader. So we can now compile the code, similar to what we had before, so Java-C source path. In this case, we're compiling delegation.java and putting it into the classes folder. Once compiled, we can run the code. So we can do java -cp classes and then com.pluralsight.delegation and leave this run. And we see it prints out 3 class loaders. So we get the app class loader, we get the extension class loader, and we get the bootstrap class loader. So one more thing we can do with this delegation list is we can print out a list of the URLs that the class loader is trying to load its classes from, i.e. the locations that it's trying to get the classes from. And we can do that by adding another loop. So we can walk out to each class loader and call get URLs, and this will return a collection of the URLs we're loading from, and then we simply print out the path for each of those URLs. And we just tab this and add a new line onto the end. So if we save this, go back to the command prompt and compile it again, and then run it again, we now see that the app class loader is trying to load from demos classes. The extensions class loader is trying to load from everything in the extensions directory, and then the bootstrap class loader, that's returned null, so we've dropped out of the loop and we're not listing what it's loading, but this is trying to load our bootstrap classes.